The Fourier transform is nothing but the front view of a wave. Imagine if you shift your perspective, or if you take the wave and rotate it by 90 degrees in a horizontal plane, what would you see? That is the Fourier transform. So just for an example, just imagine a setup of a prism onto which light is thrown, such that this prism, as it always does, splits the light into its individual spectral components. So you get an entire spectrum of red light to violet light. Now all these light waves are coming towards you. That is, from the prism, they are coming straight towards your eyes. The prism not only splits the light into spectral components, but also rotates all the waves towards you in a 90-degree horizontal plane. Now let's say you arrange all these in the order of the increasing frequencies and plot them on a graph, on a curtain put right in front of you. So now, instead of all these waves, all these spectral components hitting your eyes, they are coming onto this curtain. On this curtain, you draw a graph. This curtain has to be assumed to be a bit translucent. So even if the light is hitting it on one side, you can see from the other side, at least slightly, the spectral components, the colors that is spit out by the prism. Now say red comes first. All these things are to be arranged in the order of the increasing frequencies. Red light is of the lowest frequency. It is of the highest wavelength and the lowest frequency, so it will be first in the order. It will be followed by orange, then yellow, then green, then blue, then indigo, and then violet. This is the Fourier transform, what you're plotting onto this curtain. So let's just now look at the formula. What you see is xt is nothing but the wave. It may be the spectral components involved in the wave, in the light. So e raised to minus j omega t means rotation. E raised to I theta means rotation in a vertical plane, just as x, y and z denote moving along the three dimensions spatially. I, j and k would mean rotating in three different dimensions. I would mean you are rotating towards the right or the left in a vertical plane. J would mean you are rotating in a horizontal plane, and k would mean you are rotating from back to front or front to back, so on. Anti-clockwise direction is considered positive when it comes to rotation, and clockwise rotation is considered negative. As always, this is the convention that is used for rotation, just as there is plus x and minus x, a convention that is used, plus y and minus y. Similarly, there is plus j and minus j. So now going back to the formula, what we get is xt, that is the wave component or the spectral component, multiplied by e raised to minus j omega t. Whenever you multiply anything by e raised to minus j omega, this means you are rotating that thing in a horizontal plane. E raised to minus j omega means rotating in the horizontal plane in the anti-clockwise direction. Now, is it always necessary to think in terms of the wave rotating? What if instead of the wave rotating in a horizontal plane by 90 degrees, you keep the wave as it is and you rotate, you move along a horizontal plane to see the front view of the wave? Isn't that possible? So when you are seeing the real side of the wave, the amplitude side of the wave, the way it is usually denoted in textbooks, That is one perspective. But now let's say you pluck out the wave, and instead of rotating the wave in a horizontal plane, you move yourself to the side such that you now perceive the imaginary side of the wave, the so-called imaginary side. It's not imaginary, it's not a figment of your imagination as sometimes it is taught. It is just another perspective or the front view of the wave. That is the Fourier transform. It is also called as the imaginary side, the imaginary component of a wave. The real component is the side view of the wave, and the imaginary component is the now there is another way to visualize this entire setup. The question arises that is it necessary to always rotate the wave? Can't you rotate so that you get to see the different perspectives? And that is what this image shows. It is not necessary to always rotate the cylinder in a horizontal plane to see the different perspectives of it. You can keep the cylinder as it is and you can keep rotating. If you shift your perspective by 90 degrees, you will get to see the different components of the cylinder. Whatever you see in nature, the different colors is light coming and hitting you onto your eyes, the front view of light. So what your eyes capture is the Fourier transform, the imaginary part, the wave. Whatever you're seeing are excerpts from an e-book which is written. Now the Laplace transform, on the other hand, is seeing the real part and the imaginary part. This is done by tilting the wave in a horizontal plane at such an angle that you are able to see partially both the front view and the side view, and that is why in the equation of the Laplace transform you will see e raised to the real part and the imaginary part. Whatever you are seeing is basically excerpts from e-books that I have written. Imagine an e-book or a set of e-books in which all the building blocks of mathematics are explained with the help of down-to-earth animations, as you are seeing in the image on your screen. There are 3 e-books: Visualizing Math 1, Visualizing Math 2, and Quantum Leaps. The links to these books is given in the description below. In these books, things like complex numbers are explained with the help of examples like these. I raised to 0, I raised to 1 is rotation by 90 degrees, I raised to 2 rotation by 180 degrees, I raised to 3 rotation by 270 degrees, I raised to 4 rotation by 360 degrees, and so on. I raised to any multiple of 4 basically will be equals to 1 because it denotes one complete rotation or integral number of rotations. Other examples like complex conjugates can be seen as vertically opposite mirror images of each other. The transpose of a matrix can be visualized as the entire matrix rotated by 180 degrees about the diagonal. That is why the transpose of a matrix is the matrix back to square one, because it's a rotation, because it denotes a rotation by 360 degrees. Sine theta can be seen as a measure of how much perpendicular two forces or influences are. For example, at 90 degrees when the ball strikes the wall, the impact is maximum, and at 30 degrees it reduces to half. Sine 30 equals to half. You might have seen this formula that log a into b equals to log a plus log b, and wondered as to why this formula exists. How can multiplication on one side lead to addition on the other side? Once again, the link to these ebooks is given in the description. So that was all from my side. Thank you.